In this video, we're going to be talking about dividing rational expressions. It's the last way that we are going to combine these radical expressions. We're talking about things with square roots. A radical expression is something with a square root. When you're dividing radical expressions, so we've sort of talked through the simplified form of a radical. We've talked about simplifying these radicals. And so we don't want a factor to a power greater than the index. So if I had like the cube root of x to the fifth, this power is higher than the index, so there's a way to simplify that. We don't want a radicand with a fraction. We could fix that if our radicand had a fraction. So if we had like 3 over 2 inside a square root, we don't really want a fraction inside there. And specifically, we don't want a radical in the denominator of a fraction. This is the big one. We don't want a radical in the denominator. The way that we're going to fix the radicals in the denominator is called rationalizing the denominator. And we'll see as we go this idea right here that a square root of one fraction is the same thing as the square root of the top over the square root of the bottom. And so rule 2 and rule 3 really go together, that any fraction is really telling me that I have a radical in the denominator. All right. To simplify radicals, we can still use the properties of exponents that we had. If you go back and watch the exponents video from the beginning of this unit, the exponent rules still apply. So my exponent rules here say that this square root is the same thing as square root of 6 minus 4 would be a to the 2. If I'm dividing things with exponents, oh, I'm sorry. No, that's absolutely not right. They have to have the same base. So if that was an A and an A, then we would be in good shape. Here we don't have an A and an A. But what I can do is say that's the same thing as square root of A to the 6th over square root of B to the 4. And then look at each piece separately. So A to the 6th is 1, 2, 3, 4, 5, 6 A's. B to the 4 is 1, 2, 3, 4 B's. And the way that we've been simplifying these radicals is by finding buddies, right? And these indices are both 2, 2. So we're looking for pairs of 2. Got a pair of 2, a pair of 2, and a pair of 2. That just gives me a to the 3rd. They all get to come outside. Buddies get to go outside. Please go back and rewatch that video about simplifying radicals if you're not familiar with this. Buddies, that's B, 2 sets of those buddies. They get to come outside. All right, same thing with the second item. Is we can look at the top separately from the bottom. The indices are a little bit different this time. We're looking for groups of 3. So on the top, 81, y to the 5th. On the bottom, x to the 3rd. I'm sorry, my handwriting just got really sloppy there. Let's fix that 5 as well. All right, on the top, that 81 will break down. 81 is the same thing as 9 times 9. 9 is the same thing as 3 times 3. 9 is the same thing as 3 times 3. Those are all prime. And so I have 3, 3, 3, 3. I have 5 y's. 1, 2, 3, 4, 5. And on the bottom, that should have been x to the 3rd. You see that? All right, looking for this time, not pairs, but groups of 3. Because our index is 3, we need groups of 3. There's a group of 3. There's a group of 3. And this x to the 3rd, I should have written as x, x, x. There's a group of 3. So what's left on the top? The 3 will come out. The y will come out. The x will come out on bottom. On the top, there are still things left over. That 3 and those 2 y's. So 3 y squared is left over inside. That's the best we can do there. Notice on both of these examples, remember on that last slide what we said is we don't want to leave a fraction inside of a square root, so we didn't do that. There's no fractions inside a square root. And very specifically, we do not want to leave a radical in the denominator. We don't want to leave a radical in the denominator of a fraction. So look at the denominator of our fraction, there's no radical left. Look at the denominator of our fraction here, there's no radical left. So we are clear. Let's do the same thing here. Okay, so this was what I was trying to get out earlier. I'm sorry, I got ahead of myself. Is that we can still use the rules that we used. We can still use the exponent rules that we used several lessons ago. So this can combine. These rules go both ways. So the 4th root of something over the 4th root of something is the same thing as having the 4th root of that whole fraction. 8 p to the 7 over p to the third. And then I can just use my exponent rules. Fourth root of p to the 7th over p to the third is just p to the 4th. If you're dividing things with the same base, you could subtract their exponents. All right, 8 breaks into 2 and 4. 4 breaks into 2 and 2. And so this is the same thing as the fourth root of 2, 2, 2, and 4 p's. Since the index is 4, I'm looking for groups of 4. There's the only group of 4. And so I'll have the p come outside. 2 times 2 times 2 is 8 stays inside. All right, the last thing that we really need to talk about, and the toughest part of this lesson, is rationalizing the denominator. So if we can't use those tricks that we saw earlier, if we can't just simplify the denominator by itself, like here, we were just able to simplify the denominator. It broke down into perfect little pieces. And here, we were able to combine the fraction and divide the denominator away because the bottom and the top matched up. If we're not able to do that, so here, for example, 6 over square root 3, we're not able to do that. We can't break the 3 down. We can't divide the 6 into 3's. So what we can do instead is what's called rationalizing the denominator. Here's what you do. If there's only one item in the denominator, what you're going to do, you only care about the bottom, right? You don't really care about the top. Those rules that we looked at, those 3 rules, we're talking about we don't want a fraction and a square root, and we don't want a square root in the denominator specifically. What we're going to do is we're going to multiply by that thing. So we're multiplying by the thing that was in the denominator. This right here is what we're multiplying by. That's if there's only one item. All right, what we get out of this is 6 square root of 3 over square root of 9. What's the square root of 9? And then 6 over 3, the things on the outside here, we can divide. 6 divided by 3 is 2. And look at what we got. We got something, we started with something with a square root in the bottom, and we got something that does not have a square root in the bottom. Perfect. That follows the rules that we wanted to follow. All right, that's if there's one item in the denominator. If there's 2 items in the denominator, this is what we're trying to get to, okay? If there's 2 items in the denominator, what we're going to do, let's say we're going to ignore this. We'll show this in a second. What we're going to do is we're going to multiply by the conjugate. So negative 2 over 2 plus square root 6. We're going to multiply by the conjugate. And remember, we don't care about the numerator here. We care about the denominator. So I'm going to multiply by 2 minus square root 6. 2 minus square root 6. The word conjugate should sound familiar to you from the last lesson when we were multiplying radical expressions. All right, on the top I need to distribute. That would give me negative 4 plus 2 square root 6. On the bottom I need to distribute as well. I'm going to FOIL. So first and first, 2 times 2 is 4. 2 times negative square root of 6. Positive square root of 6 times 2. And square root of 6 times negative square root of 6. All right, let's focus on the bottom for a second. Notice that these 2 items are the same but opposite. Those 2 items should cancel out every single time. They're opposite things. Positive 2 square root of 6 and negative 2 square root of 6 add up to 0 square root of 6, which is just 0. All right, let's keep going. We've got negative 4 on top plus 2 square root of 6. On the bottom I have 4 minus the square root of 36 is just 6. All right, that gives me negative 4 plus 2 square root of 6 over 4 minus 6 is negative 2. And then I can actually divide all 3 of these items by that negative 2, right? Since I can divide both of those by the negative 2, I'm going to go ahead and do it. Negative 4 divided by negative 2 is 2. 2 divided by negative 2 is negative 1. 2 minus 1 square root 6. And let's see if that matches up with the answer we had here. It is. And notice that we started with something with a radical in the denominator, right? And by rationalizing, we end up with something with no radical in the denominator. And that was the rule that we wanted to meet. That was the situation we wanted to have, was no radicals in the denominator. All right, rationalizing the denominator. Again, we have one item in the denominator, so what we're going to do is we're just going to multiply by that thing, square root 7, square root 7. So that gives me square root of 7y to the 5th over square root of 49. This 7y to the fifth is the same thing as 7. Y. We do want to simplify if possible. And the square root of 49 is just 7. Notice we got buddies here. So that'd be y squared, square root of 7y, all over 7. The 7 and the y didn't have buddies, so they had to stay inside. That's the best answer we can get here, but notice that it does follow the rule. We started with a fraction inside a square root. We don't want that. Specifically, we had a square root on the bottom, and in the end, we do not have a square root on the bottom. All right, this is the idea that I was just showing you. When you are multiplying, when you have two terms on the bottom, to get rid of the two items, we can look at multiplying conjugates turns into a difference of squares and gets rid of those two middle items. So, for example, 2 plus square root of 6, 2 minus square root of 6. We actually saw that exact example before. 2 plus square root of 6, 2 minus square root of 6. They multiply, the middle things cancel, and we end up with just a negative 2. So, negative 2 over 2 plus square root of 6. Didn't we just do this one? Yeah, we did that exact one right here. Negative 2 over 2 plus square root of 6. We will not do that example. We'll find another. Actually, you know what? We could just make one up. What if we had something like this? What if we had something like 3 over 4 minus square root 2? Take a second and pause the video and see if you can work this out. The next one is going to be more difficult, so we want to make sure that we can do the easy one first. So again, we're focused on the denominator. What we're going to multiply is 4 plus square root 2. And remember, in the end, so here we have a square root in the bottom. All we're hoping is that we get something without a square root in the bottom. We don't want a square root in the bottom. On the top, when you distribute, you get 12 plus 3 square root 2. On the bottom, when you distribute, you get 16 plus 4 square root 2 minus 4 square root 2 minus square root 4. Notice what I promised would happen did happen. The two middle items are the same but opposite. 12 plus 3 square root 2 over 16 minus the square root of 4, just 2. And 16 minus 2 is 14. And notice our answer does not have a square root in the denominator. Check. We have done what we came to do. All we care is to get something that does not have a square root in the denominator. We would want to simplify it if we could, but to simplify this, we would need all three of these items to be divisible by the same thing. And here, 12, 3, and 14, they have no common factors, so there's nothing we could divide them both by. All right, hardest example. This is the next, oh, I'm sorry, this is not the hardest example. There is one more difficult. This is the next hardest example. I'll give you a second. Why don't you pause the video and try it? This is what I'm going to multiply by, is by 3 minus square root 5. When I did that, this is what happened when I distributed. Notice these terms on the bottom. The middle items go away, as promised. The square root of 5 squared is just 5. 9 minus 5 on the bottom is 4. Notice here that the 24, the 8, and the 4 are all divisible by 4, so you could divide them all by 4. We actually got a really nice answer out this time. And there is not a square root in the denominator, and that's what we wanted. All right, final example. Take a second to think about what is going to be the conjugate of the bottom specifically. Remember, we don't care about the top. We want to multiply to rationalize the denominator. Rationalize the denominator. What I would be multiplying by is the square root of x plus 7. All we're doing is changing the sign in the middle. If it was a minus, we change it to a plus. If it was a plus, we change it to a minus. This is what happens when you distribute. You just have to distribute top and bottom this time. That's why this one's so difficult. I'm seeing a lot of like terms here. That is the same as that. The square root of x squared is the same thing as just x. Those two middle, the two that I circled, the 4 square root of x and 7 square root of x, turn into 11 square root of x. And the 28 just came down. Those two middle terms, like I said, are always going to cancel out. And the square root of x squared is the same thing as just x. This is not a super nice looking answer like we have been getting, but that's as simple as we can get it. And notice that the denominator does not have a square root, and that was our goal. So here the denominator had a square root. Down here, the simplified version, the denominator does not have a square root. And that is how you divide and rationalize denominators with rational expressions.